Hey everybody, BTO Pro here with another annoying intro coming to you live from the future or wherever someone dressed this way is coming from. Very shiny glasses. Anyway, I am back writing a series about the work I've been exploring around web components and micro front end technology. So we're hooking web components up to Vercel. By web components, I always mean lit. Just please use lit, use lit, use lit. Stop complaining, use lit. It's fine. Use lit. It's still way faster than everything else that's ever existed previously. Okay, after that. I've got this DuckDuckGo example that I stepped into in the second post here. The third post, which I'm working on right now, this video is from the bottom of, is all about the MicroFrontendRegistry. So there's a bit of magic in this article. It's just kind of like, hey, you go to a search form, and we've selected this so that you can call this magic thing, and voila, you have DuckDuckGo results. You probably want to know why. All right, so you can check this out. It's in the links in that article. You go to lrnwebcomponents.vercel.app. It also is available at, I think, like hacksapi.vercel.app. Yeah, there we go. Same monorepo. This is our monorepo wired up to Storybook. And then we've got stories of our elements. Now, not all these elements use Vercel, but a bunch of them do. So if I type micro, we're going to see there's a category for micro front ends, and we've got a whole bunch of different ones. Now, the other articles will go into some of these other more fun ones, like simple image. It does image conversion and compression and rotation, things like that. But for right now, we're going to go to DuckDuckGo. Go to DuckDuckGo, and in DuckDuckGo, you can see I've searched for all kind of stuff. Let's search for State College, and we see we have no results. Things, there we go. Things came up with something. Thanks, DuckDuckGo. So what you're seeing here is just a dump of the call that went across. Now let's see what happens when I actually go and issue this call. We'll go to per network, and we'll check out XHRs, and then we'll move this window over. Okay, make it a little easier to read. So things, let's search for the ever wonderful lit element. Element. Search. Not getting any results there. How about just lit? There we go. There's results for lit. Oh, the band lit. Okay. So DuckDuckGo, we can see, is called with a payload that literally just sends the word lit. And it's hitting API/services/website/DuckDuckGo. Then it's responding with JSON. And what we're getting in that response here is more or less just a straight scrape of what came back from DuckDuckGo. So starting at that code that's running, right? It's just a form. They click the button, basically. There we go. So, and this is described in the article, but we've got just a simple div, right? We've got an input field, ID is search, and click the search button and then show the results below. Nothing crazy here. So search, trace down a bit, right? On, I believe this is, because this is purely an example element, just basically for writing this article. So on first updated, which is lifecycle hook in lit element, we are going to say, okay, well, do we have a search button in our shadow root? If we do, add a click handler. And then if it's clicked, we're going to run this anonymous function. The anonymous function is just going to very quickly take the search value from that input field, assign it to Q, and then we're going to call MicroFrontendRegistry.call at core/DuckDuckGo. We're going to pass it the params in question, just the Q. And then we're going to have DDG callback, which is binded to the context of this. So imagine that goes out the door to that service. We wait some unknown period of time, and then on return, it calls DDG. Now, in other examples, we'll show in the future, this is actually returning a promise. So you could just do async await, and you could get your message back from the micro and keep moving forward. In this, I'm just calling this callback. So DuckDuckGo callback, we can see I'm console logging the related topics. And then we're taking related topics and we're printing that out. That's why some of the stuff didn't actually return anything, because it didn't have any related topics. So nothing too fancy there, right? We start with input from the user. They hit a button. It magically goes somewhere. So how does it get there? So how it gets there is through the MicroFrontendRegistry. And so I've already got some core services established. We've got some experimental services. We've also got things for Hack CMS, which is one of the platforms we're developing this stuff for, is a content management system that's headless. So if I look under microservices, we're going to see code that implements DuckDuckGo in this case has a call for core services. So we're importing enable services, and it's just going to say run enable core services. And all enable core services does is just a function that goes through and leverages the micro front end registry. Now, I've patterned a little bit of this off of like the way the custom element registry works. Not exactly, just like it's more inspired by sort of a thing. You know, those films that don't actually have anything to do with the topping material, but they just say inspired by true events. Think of it like that. So we can see here, got DuckDuckGo, there we go. So we've got MicroFrontendRegistry.add, and we're going to pass in the endpoint in question, which is like where to go find this file, name, which is going to be the way a developer, in this case me, calling in that one line, like how am I referenced, right? Went with the @ symbol approach because I liked that from like an org status in NPM. So imagine, you know, you could be registering these different microservice endpoints that you're going to call from your micro front end. So this one is /DuckDuckGo. It's just got a human readable title, description, and it's saying we're not doing validation on this yet. I haven't, you know, decided whether we're going to do that. But it's saying, hey, you need a queue for query parameters. Honestly, it might be more of like, hey, you didn't include these. You get into like, I would have to really flesh this out because of like this, right? Like quality is optional in this screenshotting service that we made. So we actually have a lot of services registered this way. As you can see, let's scroll through. You know, there's a dozen or so. And some of them are, you know, experimental, as it says down here, like doing SSR hydration this way, which is not really working. Or building a glossary, which is highly specific to Hack CMS, and it's not a core service. But we got a whole bunch of them. We'll go over several in subsequent posts. But what we're focusing on is DuckDuckGo. So it's defining, hey, there's this endpoint. And when someone asks for @core/DuckDuckGo, effectively it's going to throw a fetch at this endpoint with the data in question, which it assumes to be the query parameter. So looking at the micro front end registry itself, right, when we do .add, it's basically just a shortcut for define. You could just call define, but so it's going to add in the parameters in question, right? It's going to check and make sure we have an instance of a class called MicroFrontend that just does some very basic key validation to ensure it exists. We're going to step through those keys, make sure that they're valid ones we can use. We're going to see if the endpoint starts with /API/, and the reason for this is in the context of how these are being built, particularly with Vercel, that's where you can throw your microservice endpoints into your Vercel app. You can throw them under a /API. So for the purposes of what we're building, there is a bit of first-party integration, if you will, for Vercel at the moment. I would love to get feedback on how to make this even, you know, sufficiently more abstract, or how to register endpoints, things like that. Haven't got there just yet. So we support a base for rewriting where these come to. Have that some future examples hopefully on Coped. But effectively, this is the part that makes developing locally really easy with this stuff. So let me show you my local development workflow with this. So I'm going to go to LRM Web Components. I'm going to do yarn start. Yarn start, in our case, it's in our mono repo. Fired up the storybook. You can see there's localhost 8000. Then I'm going to do, open another window. I'm going to do Vercel dev. And what Vercel dev is going to do is effectively bring to life those /API endpoints. So through this little trick here, saying, well, if the origin starts with localhost, because we're doing local development on this thing, switch that from 8x whatever over to localhost 3000, which is primarily where Vercel runs. Again, very much open to feedback on how to make these things better. And then fallback of fallbacks. I just say, like, if you don't know where we are and we're out in production, just have this as the backup. Now, this is just for things that start with /API. You could have a full qualified URL. In fact, in the article you hopefully read, getting to this point, we actually, where is it? There we go. The screenshot service does come from a full URL. It's out there. It's saying this is out in production. Unfortunately, due to limitations associated with AWS Lambda, I can't run full Puppeteer alongside everything else we're developing. Puppeteer is very big library. It's going to have to pull in Chrome, copy, or Safari or Firefox or whatever. So it's pulling in the whole executable to be able to then run and take a screenshot of the browser or whatever. In a production environment with an endpoint like this is going to use some other libraries to get the job done. So I actually had to move this out of the normal series of API calls that we have with Vercel. So DuckDuckGo gets called, or it gets registered here, and we're basically just shorthanding the way that we would then go and call this consistently with some very simple things like, hey, get me the definition of this. Does this, do we have this in the registry? You can update some things by setting them, and then call, which is the most important one. URL is also a good fallback, but call is going to allow us to call that in a single line, like we had in DuckDuckGo. Hey, go call @core/DuckDuckGo with these parameters, and this is a potential callback, which is optional, and this is the calling item in question if you want the data to, issue the event against a different specific DOM node. Only had that use case once so far. So then we do very simple. Hey, do we actually have something named that before we bother calling it? We do. Oh, great. Okay. Generate form data. If we, if we have something that is in the instance of form data, this is how we could take data directly from an info form, like a file upload, something like that. Or we just take the parameters in question, stringify them, send them in the body, get the response back. Otherwise, throw a fake, response that we had a 500. This would be, hey, the microservice isn't there at all. It did not respond in any way. And then issue the callback. And if we have the callback, then, do its thing against the caller. So if we don't have these, you can see right here, we return the data. And this is async. We are awaiting our fetch. And so you could just async await the call coming back, which will get you the data from the endpoint. There's another aspect of this instead of calling, which will come up in the image example later on. And that would be generate me a URL. Now this is different because call is actually going to go fetch the thing in question, right? And imagine this endpoint, it's built out what that is. Whereas URL, imagine this is like, okay, well, we've got an image source. It's going to be hitting some script. And in the past, it'd be, like generate my media.php or whatever, right? In this case, it's going to hit this microservice with a bunch of parameters, and our img src equals that endpoint is going to actually render whatever the heck just came from it. Could also be useful for click and then it downloads, a PDF, or click and it downloads an HTML file, things like that, right? So it's not a dedicated, hey, go fetch a thing. It's like actually sending you to a URI, and then the URI is doing something in question. So slight difference. It ultimately gives you the same, flexibility. So then, and this is not something that's like standard that I know of. I've always done things this way. Our singleton, we make an HTML tag, even though it's a registry and it's this abstract class, we still make an HTML tag, and it's affixed to the DOM as a single instance. Then if things want to request the registry, they're effectively attaching a DOM node. I just do that for ease of access when I'm debugging, among other things. And then we export the MicroFrontendRegistry, which is calling this. So effectively calling this file or pulling in this MicroFrontendRegistry is going to affix to the DOM this class. So by having that registry, we're now able to call DuckDuckGo in this case. So I've come up with a bit of a structure here that I had to tease out. So under API, which is, again, like very specific to Vercel, but if you haven't used Vercel, anything under the API directory that has a whatever.js it's going to more or less expect that this is like running Express. And so if you set up these individual calls to assume that there's a request and a response, and that we're exporting a default function called handler, it will just work in this awesome microservice way and doing this one dedicated thing, spinning up and down on AWS Lambda. It's pretty slick. So for this case, this is under services. We can see I have apps with HackCMS being the first app, some experiments, some plugins, which those haven't been fully built out yet. And then JWT, JSON Web Token, stuff for the future. So under services, we have media, text types of services, and then DuckDuckGo. So DuckDuckGo is leveraging, and this is kind of also our like example that I use to help the rest of the members on our team get an idea of how we could build more of these. So it's got this simple handler. In this case, we're pulling in request.query, which is in this case Q, right? The Q variable. So request.query.q. Then I've got this method that just kind of does some normalization, sanitization of body response information. Make sure that we have Q off of body.q or in the Q variable. And then if we do, then we're going to fetch the DuckDuckGo API with the query in question, return the search results as JSON. If we got a 200 response, then we're going to issue a standard response, which takes the response object and then throws the search results back to the user as JSON. And the other nice thing this does is it's going to cache this hit for a day. So I go to the production endpoint, I call for Lit. Give me all the articles about Lit. And it says the related articles about Lit has to do with Lit the band. And I go, cool. And then the next person comes within 14 hours and they go and issue the thing. Well, 24 hours within that 24-hour period. Well, I was just giving an example. It's 14 hours later. So they go and issue the exact same call saying, man, I'm really invested in Lit. I need to know about this band. Let's do this. DuckDuckGo. And they type in and they hit the button and bam, edge cached. So this is going to ensure, again, getting very Vercel specific here, but use some pretty stinking cool stuff with Vercel, that we get our response and that it's cached edge in their edge network. So then lastly, if we didn't have the necessary parameters, we invalidate this request and send back the reason why to the user. Now I'll step through more of these in the future, like as we get into Markdown converting to HTML, image converted to ASCII text, HTML to PDF, HTML to Markdown, HTML to docx file, docx to PDF, docx to HTML. We can do some image manipulation, right? And get into some pretty sophisticated stuff we can do with media, but it's always going to have using these same helper classes. It's going to make sure that we've got legit input. It's going to invalidate the request if we don't have the right things. It can run some other stuff from NPM in this case. And then it's going to issue our response back. In this case, it's sending an image to the buffer for the image one. So we'll go through those at a later point in time. Now, we've got our data here. And then in the end, when it's sent back, that's what you see right here in these search results. So I hope this was a useful demonstration stepping through this. I hope this entire tutorial, article series becomes useful, even just to get it as a reaction to how to potentially go about building these things. So hoping in the next one, we're going to start to step into some more sophisticated examples. But tune into this the micro front end web components series here on dev.2. I'm going to keep adding in more and more complexity on the front end lit side as far as how complex the web component is and what it's doing, as well as on the back end or back end here microservice side. So BTO Pro dressed very interestingly today. And I will catch you later, internets.